Welcome to This Explainer, where we're going to dive deep into a comprehensive playbook for fixing broken sprint planning when you're integrating machine learning and data science workflows. Let's be honest, if you work on a mixed discipline team, you already know the pain. Trying to force-fit data science into traditional software engineering sprints, it usually results in missed deadlines, frustrated engineers, and daily stand-ups that feel way more like daily apologies. Well, today, we're going to completely overhaul that process and show you exactly how to structure your sprints for actual success. Take a listen to this insight from a Scrum Master who actually manages a massive mixed team of 12 engineers and 4 data scientists.
The absolute fundamental problem we're dealing with is treating probabilistic model work exactly like deterministic engineering work. It just doesn't work. If your model doesn't hit its accuracy threshold, you should be shipping a fallback, not some incomplete model, right? Embracing this reality and strictly separating firm commitments from progress goals is what prevents that constant exhausting friction of comparing apples and oranges.
So here is our roadmap for today. We're going to cover 1. The ML sprint problem, 2. 4 ML story types, 3. The sprint planning checklist, 4. Managing ML sprint risks, 5. Real-world case studies, and finally, 6. 5 common mistakes.
All right, let's jump right into part 1, the ML sprint problem. You know how traditional sprint planning works, right? It assumes all work is homogeneous. You estimate features and story points based on complexity and time, and you commit to shipping them. And hey, this works flawlessly for deterministic infrastructure. If you're building a standard login page, an API, or spinning up a database, if the code is written correctly, it simply works. But model development, it is empirically uncertain. Because data science is essentially just the scientific method in action. You hypothesize, you test, you learn. So it simply cannot be mapped to the deterministic point scales we use for building standard software. You literally cannot estimate deterministic infrastructure and uncertain model development on the exact same numeric scale, and you definitely can't commit to the same timelines. Instead of story points, model development requires effort-based estimates. Think t-shirt sizing, like small, medium, large, that gauge the complexity and the unknowns, rather than trying to guarantee a specific delivery time.
Let's look at a typical real-world failure scenario. Picture this. You falsely commit to shipping a 13-point feature in a single sprint. You've got 8 points for the engineering API and 5 points for the data science model to hit, say, 85% accuracy. Weeks 1 and 2, engineering sprints forward, making great time. But the model team's experiments reveal that their first approach just isn't going to work. So by weeks 3 and 4, data science has to pivot, which leaves engineering completely blocked, just sitting there waiting for an API structure. By week 5, the model only hits 78% accuracy. So what's the result of all this? The sprint ends with only 20% of your story point commitment met, and absolutely no one is happy. The wild thing is, the estimation wasn't actually the problem here. Treating the model like a predictable API was the problem. This exact disaster scenario is what the rest of this explainer is going to solve for you permanently.
That brings us to section 2, 4 ML story types. Your new blueprint requires a massive conceptual shift. You need to abandon the idea of a single feature story entirely and separate your work into 4 distinct categories. Type 1 is your infrastructure. Think APIs, UI deployments, the plumbing. Because they're deterministic, you estimate these in standard story points, and they represent a firm commitment to ship. Type 2 is model development. For instance, optimizing a model toward an 85% accuracy target. You estimate this in t-shirt sizes based on effort and unknowns. And your commitment here? It is purely a progress goal. You're committing to the effort of the optimization. You are not guaranteeing the final accuracy percentage. Type 3 is research. Let's say you're prototyping whether an LLM or classical NLP works better for a problem. Again, use t-shirt sizing. Your commitment here is a learning goal. And it's so incredibly vital to remember this. Knowing that a model won't work is still immensely valuable sprint progress. Success simply means you definitively answered the research question. Finally, we have type 4, data preparation. This is stuff like collecting and labeling data. This gets a mix. Use points for deterministic integrations and t-shirt sizes for the uncertain, messy data cleaning work. Success here just means the data is ready to go. Trying to mix these different commitment models into a single story is exactly what creates friction. You've got to separate them out.
Moving right along, let's talk execution in section 3, the sprint planning checklist. You can't just show up to your sprint planning and wing it. You need a strict 3-phase structure. In phase 1, before the meeting even starts, you absolutely must assess previous blockers, check current model progress against your quality targets, and critically, verify your data availability. Are you blocked right now because you're missing training data? You need to find that out before you ever step foot in the planning room. In phase 2, during the meeting, vocabulary is everything. I mean, literally the words you say. You must explicitly separate Type 1 commitments from the rest. Start using phrases like engineering commits to shipping the API versus data science targets achieving 85% accuracy. This really simple vocabulary shift completely alters the psychological safety and accountability of the whole team. From there, detail your critical path dependencies. These usually flow sequentially, from data prep over to model training and finally ending at feature integration. And then phase 3, after the meeting. Publish the plan, but do it with explicit exit criteria. Make your decision points crystal clear. For example, explicitly state, if the model doesn't reach 75% accuracy by day 7, we immediately pivot to our fallback approach. Now, what about when things go wrong? Let's dive into Section 4, Managing ML Sprint Risks. For every single sprint, you must identify 4 very specific risks, gauge their likelihood and impact, and assign exact mitigations before the clock even starts. Risk 1 is data dependency. If your labeling falls behind, your model training stalls out. The mitigation here is doing data work in parallel during the prior sprint, or simply having a minimum viable backup dataset ready to go. Risk 2 is unachievable model quality. Say you aim for 85%, but you just hit a wall at 75%. The detailed mitigation strategy here is to define both an ideal target and a minimum quality floor. This is absolutely crucial. If you hit that minimum floor but miss the ideal target, engineering can still confidently build against it, which keeps your forward momentum alive. Risk 3 is infrastructure not being ready. To fix this, you define your API contracts before anyone starts writing a single line of code. That way, engineering can build the infrastructure in parallel with the model training. And finally, risk 4 is scope creep. Let's face it, data science is inherently exploratory, so scope expands super easily. You mitigate this by explicitly defining boundaries during planning. And if it does expand, you explicitly decide mid-sprint whether to cut other work or extend the deadline. No silent slipping. Okay, let's see how this actually works in the wild. Section 5, Real-World Case Studies. Let's detail how 2 industry heavy hitters tackle this exact problem from slightly different operational angles. Spotify uses what they call parallel tracks. Their feature engineering teams run on a standard 2-week story point cycle, while their model teams run on a 2-week research cycle that's based entirely on effort estimation. The magic here happens because they loosely couple these tracks. They synchronize explicitly at the start of the sprint to agree on the needed API, and then again mid-sprint to check integration progress. If the model team realizes, hey, we can't hit the target with this proposed API, they adjust immediately, right there mid-sprint. Google Brain, on the other hand, uses a much bolder tactic called quality-gated planning. They explicitly decouple the model work from the feature timeline. Their rule is super rigid. The model must clear quality gate Y in sprint N. Only if that gate is fully cleared does the feature actually ship in sprint N+1. If the model misses the gate, the feature gets pulled from the upcoming sprint entirely, or a pre-agreed fallback is shipped instead. This strategy completely eliminates that massive toxic pressure of trying to ship a half-baked model just to meet a totally arbitrary calendar date. To wrap this up and make sure you're totally bulletproof, let's hit Section 6, 5 common mistakes. Avoiding these specific guardrails will stop the constant pain of forcing irreducible ML uncertainty into rigid timelines. So listen closely. Number 1, do not estimate model work in story points. It has irreducible uncertainty, meaning your time estimate will literally always be wrong. Use t-shirt sizes for effort instead. Number 2, never mix firm commitments and progress goals in a single story. Isolate your engineering tasks from your data science goals, period. Number 3, never assume model work can just magically proceed without explicitly verifying your data dependencies. Do you actually have the labeled training data in hand? Check this first. Number 4, do not wait for models to be totally finished before building infrastructure. Define those API contracts early and get building in parallel. And crucially, Number 5, do not treat your quality gates as negotiable mid-sprint. Your minimum quality floor must be set in stone before the sprint even starts, and you need a concrete fallback plan ready to deploy. So, here's my challenge to you. Take this detailed playbook, budget 120 minutes before your very next planning meeting, and completely transform how your mixed discipline team plans their work. Take a hard look at your current backlog. Can you actually pull apart the feature stories? Can you isolate the infrastructure, the model development, the research, and the data prep? Can you assign firm story points only to the infrastructure and effort-based progress goals to the rest? Ultimately, if you're still struggling with this, you have to step back and ask yourself a really tough question. Are you managing the actual uncertain reality of your team's work, or are you just playing calendar math?